Okay, in this problem, I'm trying to see if all the forces remain constant, how far does the plane travel in the next 60 seconds? Developed a checklist of what I was going to do, which is determine the net force on the plane along horizontal and vertical directions, find the acceleration of the plane in those directions using Newton's second law of motion, and find the distance traveled by the plane using the equations of motion of kinematics. So our given is the mass of the airplane is 1,160 kilograms. Force due to gravity is 16 kilonewtons downward. Force of lift 16 kilonewtons upward. Thrust of airplane is 1.8 kilonewtons eastward. Drag force on airplane is 1.4 kilonewtons west. Speed of the plane at time 0 seconds, the velocity is 60 meters per second. The time interval that I'm trying to calculate is 60 seconds. So I set up a force body diagram, which is my force of lift, force of gravity, force of thrust, force of drag. So the net force in the vertical direction, F of y equals the force of lift minus force of gravity. 16 kilonewtons minus 16 kilonewtons is 0. The acceleration in the vertical directions, acceleration of y equals force of y over the mass. So put 0 over 1,160 kilograms. That gave me 0. Then I took the net force in the horizontal direction, but force in the x direction equals force of thrust minus force of drag, and I put 1.8 kilonewtons minus 1.4 kilonewtons equals 0.4 kilonewtons. The acceleration in the horizontal direction, acceleration in the x direction is f of x over m. So I put 0.4 kilonewtons over 1,160 kilograms. And I converted the kilonewtons to newtons, and that gave me 0.345 meters per second squared. And then the calculation of distance traveled, I use this kinematic equation, which is the change in x equals the initial velocity change in time plus 1/2 times acceleration in the x direction times change in time squared. So I got 60 meters per second times 60 seconds plus 1/2 times 0.345 meters per second squared times 60 seconds squared, which gave me 3,600 meters plus 620.7 meters, which was 4,220.7 meters, and I changed it from meters to kilometers, kilometers, I'm sorry, and I guess I've been calling it the wrong thing, and that gave me 4.22 kilometers east.